Alright, welcome to our lesson today on graphs of relations and functions. Actually, our goals is to be able to use a graph to represent a relation in a function, and of course to interpret what the graph is actually telling us. So to start, let's do a pretty simple example here. All we have here is a whole number and the double of a whole number. So we're relating our first number here to those set of numbers, and the only relation is that we're just doubling whatever the number is. What we can do now is to plot them on a graph, right? So if we can see here, our first number is 0 and 0. So 0 times 2 is just 0, so we have this point right here. And then with the number 1, right? When we double 1 or we do 1 times 2, we get 2. So our second point right here is x equals to 1 right here, and then y equals to 2 right here. Right, and then from there we can just keep going, right? So the next number, 2 times 2 is just 4. So we have 2 right here, 4 right here to get us this point. And then 3 double to 6. So 3 is right here, 6 is right here, get to this point. Right, so all we're doing here is plotting those points in a graph. And so from this, we can actually find the domain and the range of this relation. So just as a quick reminder, domain is the first element of a relation, whereas the range is the second element of the relation. So the domain is the thing that's being related, and the range is the result of this relation. So in this case, our domain will be all those numbers right here before they got doubled, and our range will be all those numbers after they get doubled. Right? So we can think of domain as an input. This is what we are feeding into the relation, and range is the output. So this is what we are getting out of this relation. Okay? So in this case, the domain is just 0, 1, 2, 3, 4. Right? So this is the domain, right? Because this is the 5 numbers that we are feeding into this relation, and the range is the output, so 2 or 0 to 4, 6, 8. Right? So those are our domain and ranges. And from this specific relation, we also notice that it is also a function, because every single part of a domain relates to exactly one thing in the range. For a relation to be considered a function, each domain has to relate to exactly one point on the range. Multiple domains can relate to the same range, but each domain can only relate to one range. And so in this case, we see that right here, this is a function. And an easy way to test whether or not something's a function is to do what we call a vertical line test. So at any point in this function, if we can draw a vertical line and only have the line touch one point, then it is considered a function. So for example here, in this example right here, right, we can start drawing a line through all those dots, but we notice that this line right here, right, this line we draw right here will go through 2 different points on this relation, which means that this is not a function. But in the contrary, looking at this graph, the bottom, right, we can draw a vertical line through each of those dots and see that it will only be 1 point for each dot, which means that this down here is a function. And so that's what we refer to as a vertical line test. And now lastly, there's one more thing to note here. Something interesting actually. We are not connecting the dots here, right? Normally if we see a graph, we would just connect those dots like so. However, we are not doing it because in our domain and range, we're only working with whole numbers. And the reason why we don't connect the dots is if we were to connect the dots, right, we are not working with whole numbers anymore. We're working with numbers like, so right here, this is 3. And this right here would be 2.5, right, between 2 and 3. Right, we will be working with this number here. 2.5 double will be 5, as you can see right here. Right, but this is not part of our domain. Right? Our domain does not include 2.5. It only includes 2 and 3, but not 2.5. So this is why in this scenario, we actually do not connect the dots. Right? So whether or not we connect the dots really depends on the question. So with that being said, let's try some examples. Right? So for the first part, are those 2 graphs here functions? And what are the domains and ranges? Right? So once again, we can quickly do a vertical line test. So even though the lines are connected, or the dots are connected, we can just do a quick little vertical line and see at any point, does any of those graphs have 2 points in a vertical line? Well, and the answer is no, right? All of them seem to be free of this vertical line here, which means that in both of those cases, they are functions. So yes to that, yes to that. Okay, so now let's find the domain of this graph. So before, in this little graph here, right? We have commas separating our domain and range because they're individual values, individual dots. So now in our graphs, the actual lines, there's a lot of numbers to consider. Actually, an infinite amount of numbers to consider. So even from this point to this point right here, there's 0 here, there's 1 here. We got 0 0.1, 0 0.2, 0 0.001. It's every single number, as long as the line is connected, it's every single number in that line. Which means all we have to do is find a range of values, right? Find like a restriction, so we don't have to list out every single number. So a quick way to determine the domain of a relation is to look at its x-axis, right? You can associate the domain with the x-axis and the range with the y-axis. So in this case, from the x-axis, we start here at x equals to 4, and we're including everything to the left of 4, right? Notice that there's no point here. This line will keep going. So the domain, in this case, would just be anything below 4, right? So x is smaller or equal to 4. This is what the domain is. As long as x is smaller than 4, it doesn't really matter, right? If x is negative 2, it'll be right here. That's within the line. If x is, say, negative 1,000, it'll be off the graph, but it'll be within a line, right? As long as it is at x equals to 4 and over there, essentially, right? And then the range, similarly, it's a y-axis, so we'll look at its highest or lowest point. So in this case, our highest point here is not 4 here, it'll be between 2 and 4, so it's 3 right here, y equals to 3. It's at 3, and everything below that, right? Because we can say, oh, y equals to 3 here. We have y is negative 2 here. But we notice that on the other side, the graph keeps going. So the range is just y is smaller than 3, and it will keep going until, I guess, negative infinity. Right? So now, on this graph here, we look at the x-axis. So in this case, sorry, this dot's kind of really oddly drawn here. Okay, there we go. Here, I just realigned the graph here because it was a little bit off. But anyways, the domain here, in this case, we'll look at the x-axis. We have 4, right? So right here, x is 4, but then it also ends here where x is negative 2, which means that this relation only exists in between x is negative 2 and 4. So domain is negative 2, or between negative 2 and 4, like that. And then similarly-ish, right, was the y, or the range here, and we notice that the highest point is at y equals to 5, the lowest point is at y equals to 1. Which means that the range is just between the 1 and the 5. Right? And that's pretty much it. So all this is telling us is that on the x-axis, this relation exists between negative 2, that's negative 2 right here, and then 4. And then, similarly with the range, it exists between 1 and 5. Right? So that's all this is with domain and range. Right? And here's another similar question you might find, is that want to determine the range value when the domain value is negative 1, or the domain value when the range value is 6. Right? So again, if we associate domain with x and range as y, we notice that all this question asking us is determine the range value when the domain value is 1. So it's saying, what is y when x equals to 1, right? Because the domain value is just x. Similarly, what's the domain value? So what is x when the range value, y, is 6? Right, so this is all it is asking us. Put it up here. So when x is negative 1 and y is 6. So we can just plug everything in, right? What's the range value? So when y equals to negative 2 times negative 1, this gets us negative times negative 1 is positive 2. So when the domain value is negative 1, the range value is just 6. In other words, when x is negative 1, y is 6. Similarly, when the range value is 6, as you can see here, we plug it back in. Right? When y is 6 equals to negative 2x plus 4. Right? We subtract 4 from both sides. So we get 6 minus 4 equals to negative 2x, which is 2 equals to negative 2x, which means that x is negative 1. Right? So when the range is 6, x is negative 1, as you can see. Right? And we can also look at our graph as well. So when the domain value is negative 1, so when the domain value is right here, that's negative 1, we can match it up to the graph to see that, oh, right here, when x is negative 1, then y equals to 6. Right? So we can use a graph as well as algebra. Right, and with that being said, here's a pretty common question or word problem you might see. Right, so we have a graph down here with n as the number of fishing boats as a function of time. So we're looking at time of the day and the number of fishing boats on this specific inlet. So we want the dependent and independent variable. Right, so as a quick refresher, the independent variable is the variable that we are essentially choosing. And the dependent variable will change depending on what the independent variable is. But in other words, all it is saying that independent variable is the x, dependent variable is the y. So in our case, on the x-axis, we have the time. And on the y-axis, we have the number of boats. So which means that the independent variable, okay, so independent variable is just the x-axis. So that is the time. And then dependent is just the y-axis. Oh, that's the y-axis, which is the number of boats. So now, why are the points on this graph not connected? Well, simple question or simple answer is just we just cannot have half a boat. Right? If we were to connect all those lines right here, then we are saying that, oh, at, let's say, so this is 9 o'clock, that's 10. So let's say at 10:30 right here, right? That's 10:30 right here. We would have, say, oh, I guess it's 11 right here, 11 boats. But let's say if it's 10:45 here, it'll be along this line. At 10:45, we should have 10 and a quarter of a boat, right? So in other words, we are working with whole numbers in this case, and we can have half a boat. So this is why the dots are not connected. So we can say we are working with whole numbers. All right, and then the domain, the range of the graph. Once again, we associate domain with the x-axis, range with the y-axis. So the domain will be all the x values. So let's see, what do we have? We have 9 o'clock, 10 o'clock, 11, 12, 13, 14, 15, 16, 17 o'clocks. Okay, so it will just be 9 o'clock, 10 o'clock, okay? And our range is all the y values. So we can see we got, right here, we got a 6 right here, we got 2 8s, we got a 9, we got a 12, got another 12 here. What is it? That's 14, we got 16, and then we got 18, right? We don't really repeat the range, right? If you have a repeated value, we just write it once. Right? What's the range? Let's start from the bottom. So we have a 6. Right here, we have an 8 or 2 8s, but we just write 8 ones, right? So that's pretty much it. It gets a lot of big terminologies, but all we have to remember is the x-axis corresponds to the domain and the independent variable, and the y-axis corresponds to the range and the dependent variable. Okay, so with that being said, do some practice questions. So pause the video here, try those yourselves, and then we'll go over them in a bit. Okay, hope you had some time to pause the video and do them yourselves, and let's get to it then. So, first of all, let's find the domain and range of the following graphs and figure out if they are functions. So we'll do our vertical line test. We just draw a few lines to all those points, and then when we get to those 2 points at the top, we realize that was one vertical line, we can 2 points at once, which means that that is not a function. No. So now for the domain, once again, the domain is all the x values. Right, so we have, let's say we got 1 here, got 2, got 3, 4, 5, 6. Right, got 6 twice, but we only write it once. Separated by commas because they are not connected. Okay, now with the range, same thing. We found all the y values. So we have a 1 here, 2, 3, 4, 5, 6. So exact same as the domain. Okay, right, so for the next question, we'll do all vertical line tests. To be honest, this is more like an artist error. But it is a curve. And it's not just a, right, it's not drawn like a straight arch like this. So, which means that this graph right here is a function. So now for the domain, right, if you look at the domain, so all x values, we notice that it starts at -2 and ends at +2, right? So this entire area right here, or this entire x-axis, in between those two numbers is the domain. The domain is between -2 and +2. And now for the range, aka the y values, notice that the top of this graph is a 3, and it doesn't go lower than a 0, right? Because we're pretty much going from the bottom of the y-axis to 3. So the range is just between 0 and 3, right? Just like that. Okay, lastly, we got the height of the tide here, dependent, independent, right? So once again, independent is the x-axis. In this case, that's the time. And the dependent is the y-axis. And in this case, it is the height of the tide. Why are the points connected? Right? So why are they connected in this case? Right? And that's because the results don't have to be whole numbers. Right? If we could see here, if we were to say draw a line here, right, at what is this? That's 9:30. At 9:30, we see that the tide will be around 0.9 meters. Right? Or in this case, the height at 11:45 will be around, what is this, 1.25 meters. Right? And as we can see, this is why they are connected, because both of our variables can be continuous. Right? They're not distinct objects. Right? We can have like a time in between 9 o'clock and 9:01. Right? We can have a measurement of the height of the tide between 10 meters and 10.1 meters. Right? Everything in the middle can be included. Again, that's in contrary to the boats, because we cannot have 2.5 boats, but we can have 2.5 meters of a tide. That's why they're connected, because the variables are continuous. Okay, and next, the domain, the range. So let's see the x values. We see that it starts right here and it ends right here. So it starts at 9 and it ends, let's see, what is that? That is at 16 o'clock, so 4 p.m. So the domain is just 9 o'clock in between 4 o'clock, okay? And then range here, that's a y values. So in this case, the height of the tide. The lowest point right here is at 0.8. The highest point right here is at 1.4. So the range is just somewhere in between 0.8. Oh, not y here. It'll be h now. And 1.4. So that's pretty much it for this lesson. So we learned how to find the domain, the range of a graph, and whether or not a graph is a function or not. So again, the most important part is the x-axis corresponds to the domain and the independent variable, while the y-axis corresponds to the range and a dependent variable. And with that, you can pretty much figure everything else out from there. Right? So yeah, with that being said, keep practicing and stay hydrated.